reason I'm going to talk about, and so therefore they are replacing this with a point-to-point unidirectional set of connections, and that and the interface, the definitions at various levels are collectively known as the Quick Path Interconnect, or QPI. So I will use the phrase QPI frequently through this talk. Like any interconnect, there are multiple layers. I'm going to say a little bit about the link layer and a little bit about the protocol layer. If you don't know what those terms are, don't think it should matter. At the link layer, what they have is a complete interconnect, or at least indirectly a complete interconnect, so that every node in the system is capable of communicating with every other node, either directly or indirectly through these unidirectional links. And they're pairs, unidirectional links. I'm not going to talk very much at this level, but I did want to emphasize, because it's very important where we're going, the technology that has been developed here. The thing that makes it interesting is that a point-to-point connection, obviously for a long wire, I first heard about this with the phone company, that when you send a signal over a long wire, if you don't terminate the end correctly, you get this reflection because it's a transmission line. And as speeds go up, the length of the wire that you can have before you start seeing the transmission line effect gets shorter and shorter. And it's now to the point where a transmission line of a couple of centimeters is long enough, a wire long enough, a couple of centimeters long is long enough to exhibit these transmission line characteristics. So what we see is a fairly ugly signal, even over a signal. I get upset when one goes out right there. Where was I? So, one of my former students is a professor now. Whenever a cell phone goes off in the audience, he announces before it goes off that if a cell phone goes off, that he reserves the right to answer the phone. And so when it goes off, he goes and he talks to the person on the phone and embarrasses everybody in the front. So I'm embarrassed. Okay, so the idea that Intel had, and it's not just Intel, incidentally, everybody has figured this out, that even when you're sending a signal down a wire that's only a couple centimeters long, the signal gets ugly because it's not a clean transmission line. And so the idea that appeared in a number of different places is that what you want to do is send an ugly signal down the wire in the sense that you know how it's going to be modified with reflections and so on, and then at the other end when it's received it looks clean. Okay, so you know how it's going to get messed up along the way, and so you invert in time what causes the mess up, and that means that you get a clean signal at the other end. So you have a circuit that looks something like this, where you're going to send this wire down a channel. The signal comes in here. It goes through. It's multiplied, maybe even inverted, with these 4 separate signals with delay. So each of these 4 signals arrives here after some delay, being either inverted or increased or decreased in magnitude, or both. So you send a signal where as the signal coming in here looks like this, and each one of these stages it looks nice and clean coming in, and then you change. Here you've inverted it and made it small. Here it's even smaller, but it's still the same polarity and so on. So you send a signal that goes down the wire looking like this, and then it goes through this ugly transmission line that has reflections and stubs and so on that makes the signal look really ugly, and it comes out the other end looking not perfect like this, but at least it looks like this, not like that. Okay. So that's the basic idea, and that means that you can go really fast. People are talking about 10 gigahertz transmission signals between chips, which is pretty amazing. So here's a picture on the left. You see, this is an oscilloscope trace. You can see that this width is lots and lots of separate signals. The signals are not very clean. If you look at the waveform up there, you can